So let's go ahead and get started. So I want Jill just to kind of introduce herself. Some of y'all may not know who she is. And after she introduces herself, she's going to tell us what she's going to be talking to us today about in science.
Absolutely. Okay, well, thank you so much, Miss Garcia, for that introduction. So hi, everybody. My name is Jill, and I work for the Upper Trinity Groundwater Conservation District. We're looking for a shorter name, it's way too long. But what I do is I am a geoscientist in training, meaning that I brought all of these really cool samples and fossils for you guys today. We're gonna be kind of talking about how geology works, and then because you guys live in Florida, and I'm actually in Texas right now, so we have like some slightly different things that happen in different parts of the country. So I thought I would show you guys some cool stuff today. In case y'all are wondering, Miss Garcia is my cousin. So we've known each other for a while. But anyway, so yeah, no, that's how we're related. But anyway, so going ahead and starting off, we've got a lot of different samples here, but a topic that you guys may have talked about a long time ago is the rock cycle and weathering and erosion and how rocks end up looking the ways that they do. Because if you guys go out on any given day, you're gonna find rocks that look completely different from each other just walking down the street. And so I'm gonna tell you guys a little bit about how that happens and why that occurs, and then some of the really cool things that we can end up with when the rock cycle happens. So I'm going to try to put some vocab words up here. This is just for you guys. I don't think you'll have a test over this or anything, but it's just always fun to see. And I know that my picture looks flipped. So like on my camera, the rock cycle looks backwards, but I'm pretty sure you guys can see it okay. So let me know, once again, just contact Miss Garcia if y'all can't see anything, need me to get anything closer to the camera, because I'm happy to. So okay, the rock cycle, what is it? When you guys hear about or read about the rock cycle, you normally envision something that kind of looks like volcanoes, right? We start talking about volcanoes, we start talking about mountains, because that's usually the coolest place to start with the rock cycle. So I will tell you that underneath the surface of the earth, that's where we have all of our liquid rock, right? It's in all of these squished areas, and it's in between cracks and things like that. Now, when you have molten rock, it's got a special name if it's above or below the ground, right? So if we ever have magma, which is the rock that is below the ground, if we have that, sometimes it'll cool and make giant shapes of crystals. So if you have liquid rock that's under the ground and it takes forever and forever to cool, you're going to end up with these gigantic crystals that look like I just colored a line on this rock. So that's kind of the stuff that you can end up with there. Now, after we get through kind of the exciting part of the rock cycle, which is we have our magma and our lava and all of that stuff eventually cools, this is where we get to some of the topics that we're going to talk about today, because the rocks, after they've been cooled from the volcano, have a tendency to not want to stay together. They usually break apart and they break into new materials. And so that's what we're going to be talking a little bit about today. Okay, moving this back. All right, so the first vocab word I kind of wanted to cover for you guys, because this is something that geologists deal with a lot. The first word is weathering. Has anybody heard of that word before? Maybe we talked about it in a science class a long, long time ago. Maybe you read about it. But the important thing that we want to remember about weathering is, oh, nice, I see a me. Excellent, okay, cool. If y'all recognize this word, way to go. So all this is the disintegration of a rock through various means. Now we're gonna get to the through various means in a second, but the important thing I want y'all to remember is when a rock is being broken down, it can be weathered or disintegrated in two different ways. And we're gonna talk about both of those. So the first way that I want to describe to you guys how a rock is broken down is called, here we go, chemical weathering. So remember in the definition where I said they're disintegrated through various means. This is one of the ways. Now, the biggest way that rocks are chemically weathered out in the environment is due to water. Surprisingly, I know, right? Because you think chemical, you think acids and like really cool chemistry stuff, right? Well, oftentimes our water actually has high amounts of acidic stuff in it. So I'm going to just give you an example. Normally geologists, or I guess, yeah, me, I suppose, we typically use something called hydrochloric acid when we're identifying rocks out in the field. Now, we'll keep a flask of it on our hips and kind of like be ready to check our rocks. That's where we also usually have our rock hammers. This is my rock hammer since I was like in college. It's been all over the United States. It's hit a lot of rocks. But anyway, so when we have this, we want to see if the rock has been affected by the acid. And so when that happens, you can actually take a rock sample and dump a sort of a family-friendly version of an acid on it. So what we have right here, I don't know if any of y'all are curious, this is white vinegar. So this is kind of a friendly version of an acid that you could go and test some rocks at home if you wanted to. I know not everybody has access to hydrochloric acid, but this is like a great second way to do that. So if we take our acid and we dump it on a rock, it's going to change the chemical makeup of the rock. The rock is not just going to be whatever it was. It's going to be something new because we introduced a new component to the rock. So this is what chemical weathering is. I don't know if anybody has ever seen videos of underground caverns with stalactites and stalagmites and cool stuff like that. It just looks like a totally different world. That's actually all due to acid. If there's any kind of ions that end up in the water, they eat and eat and eat away at the water for the rock for millions and millions of years. And so then you end up with these super funky holes in your rock. See, what kind of different. So that's the result of acid for like years and years and years and years and years. It takes a very long time for that to happen. So I'm going to attempt to pour some acid on this sample, and I'm going to try to hold my AirPod. We're going to see if you guys can actually hear the reaction of the material. And if you can't, I'll show y'all some cool stuff later, I promise. Okay, so we're going to go ahead and take, oh, in case y'all are wondering, this is a fossil that we got off of our property here where I work. So we got a lot of cool fossils all over the place. This is an ammonite. So it's got some rocks around it that would react to the acid. So we're going to be able to go ahead and pour some acid on it and figure out if we maybe have some of those pieces from that part of the rock cycle. So I'm going to go ahead and take it. We're going to dump some white vinegar. We'll see how this goes. Okay, so here we go. Dumping it on to our sample. If we were more scientific, we would use, you know, like a beaker or something, but you know. Okay, so let's see. Can we hear that? A little bit. It should be sizzling, should be making this really popping noise. So what that means is that the rock is currently breaking down as the result of the acid. So yeah, chemical weathering. Ooh. Okay, so in case y'all were also wondering, because I said several different ways, right, that rocks can break down. So the second major way that rocks break down, and this is the one that I think everybody is a little bit more familiar with, is physical weathering. So this is the one that we see a lot of. This is where if you have a rock, if you break it at all, that's considered physical weathering. That's all it is. That's when a rock is beaten up by other rocks or wind has blown through. And then in that instance, the wind makes these really cool patterns all over the rock. So you see those little layers? It kind of looks like if you chopped it in half, it would be like a delicious sandwich, rock sandwich, see that? So what that means is that every single one of these layers in the rock was wind that blew those pieces through. And so eventually they ended up making this sample. But surprisingly, physical weathering is what we see most of the time out in the environment. So I'm trying to think if there's another good sample here that shows you guys physical weathering. This is another really good sample. So I'm going to hold it really close to the camera. If everybody can see, we've got kind of some funky lines on the side of this rock. Everybody kind of see that? They go at angles. This tells us information about how the water and the wind reacted with the rock millions and millions of years ago. In case y'all are wondering, all the samples that we have here today are at least 3 million years old. So we got some old rocks. But those are the primary things that we have that show us what the Earth was like millions and millions of years ago. Because geologists are kind of like, I guess the best way to describe it is we're detectives, but we're detectives and we don't have a whole lot of information. So what'll happen is someone will find a fossil or a rock like this, for example, okay? So somebody is digging in a riverbed and they happen to find these fish. So what a geologist then has to do is they are given a task. They say, we need to look at the rocks that these fossils are in. We need to look at the fossils, and that will tell us information about what was going on there millions and millions of years ago. So if I were to pretend, let's say all of you guys, y'all are now all geoscientists in training. Way to go. Woo. So if I gave you guys this sample, you would probably be able to tell me if this was a place that had a lot of land or maybe was covered with a lot of water. Maybe if this area might have been a volcano area, or or maybe it looks more like a beach. See, you guys are hopefully kind of coming up with, those are the kind of questions that geologists have to ask of themselves and then solve usually. So it's kind of interesting. But yeah, so those are the two major types of weathering that we typically see out in the wild or out in the environment. Okay, now the cool thing that I wanted to teach you guys about next is this is a word that usually you see with the word weathering all the time. So if you ever see the word weathering in a textbook, it's always accompanied by this other word. And we're going to talk about it here in just a second. So this other major geological concept is called erosion. There we go. And so erosion, I know you hear erosion and weathering, erosion and weathering. And some of you guys might be like, Miss Jill, I do not know the difference between those. Why are they important? Why do we care? So I'm going to hopefully highlight those and you guys will have a better understanding of them. So with weathering, that usually is something that happens over a long period of time, but we see the result of it every single day. Sometimes you guys might notice that a road, as you've driven over it several weeks in a row, maybe you notice there's cracks on the edges, or maybe there was a pothole that appeared. You guys are actually viewing physical weathering because the rocks are breaking down over time. Now we need to talk about, where does all of that rock material go? Does it typically stay in the same place where the rock was broken, or does it move? And that's where our definition of erosion comes back in, because all erosion is the transport of materials from one location to another location. That's all erosion is. So if you want to kind of remember those two words together, weathering is when the rock gets destroyed, erosion is what happens to it afterwards. So we have a lot of different ways that we see erosion throughout the day. And in case some of you guys are wondering, like, okay, Miss Jill, got it. That's the definition of erosion. That's weathering. Why are they important? That is a great question in and of itself. So is anybody on the webcam, I guess, are you guys still a fan of cereal? Does everybody still eat cereal on a regular basis, like Cinnamon Toast Crunch, Reese's Puffs, stuff like that? Okay, so hopefully if you do, you have seen the labels on the cereal that say they contain the 12 essential, thank you, Natalie. All right, at least one person still eats cereal. So what they'll have on their boxes is something called the 12 essential vitamins and minerals. Now you might have seen that label and go, okay, cool, you know, like that's gonna make me healthy. Awesome, excellent. But where do we get those minerals from? Where do we get those vitamins from? We get them from rocks. That's where we get all of that material. So in case before anybody is like, oh my gosh, there's a rock in my cereal. That's not true. But what we do have is we have to grind down some of these materials that we find out in the wild, or out, so to speak, in the plains where we find rocks typically, and they'll grind them down and they'll refine the things that will make us healthy. And we put those in our food. So for example, iron, if everybody's heard, like, iron is a really good thing for you to have in your body. We just have to have certain amounts of elements so we're healthy. But in this instance, what we would need is geologists would look for rocks that are dark and heavy, because that is indication of iron being present in the rock. So everybody see this one right here, this black color? We've probably got some iron in it. Let's look at a different example. So this is actually one of my meteorites from Thailand. This is kind of cool. So it's called a tektite. I want to make sure I can show this really nice to the camera. Everybody see that? So it is from Thailand. You guys notice it is jet black. It is super, super dark. So this tells us that there's definitely iron in that particular sample, which means if we wanted to, we could refine it, take it out, and then put it in our food to make us healthy. So in case anybody was wondering, like, why is erosion and weathering, like, why is that important? Well, it actually ends up helping us be healthy for a good period of time. So things like this, different types of soil that we have, all have different types of nutrients and minerals in them, which is why they all look different, right? We've got some really light colored soils, which probably don't have a lot of iron in them, right? They're not that dark black color, to stuff that has red in it, which actually would be an oxidized form of iron. So just showing you guys, this is where all those rocks, those materials, the vitamins and minerals, this is where we get them from, is from rock samples. Okay, so in case y'all are wondering, like, what does a geoscientist in training actually do? Do you just walk around with cool samples all day? Well, normally, most of the time, what I'll do is I teach people about aquifers in Texas. Now, just in case, if anybody's heard that word and knows what it is, excellent, nice job. But I have a cute little drawing behind me for in case anybody is not sure about an aquifer, and that's totally okay. All right, so here we go. So here's my little anime looking rock here. But what we have here is an explanation of what an aquifer is. So an aquifer is a geologic formation. It's a rock, and it stores water. So this is kind of our little, this is my fake sandstone aquifer guy right here. And you can notice, here's his little cute face, but he has rocks along the edges. Does everybody see that? He's kind of got like a little pattern around him. And in between all of those rocks are different spaces. That is where, oh, excellent, awesome, everybody can see, cool. That is where all of the water actually hangs out. So it fills in all of the spaces between all of these little grains, and then people can access that water with a hole in the ground, pretty much. I know, right? It'll take me forever to color in that little aquifer guy, but you guys get the idea how it's all in between all of the different cracks. And so what my job here at the office is when people are putting those holes in the ground to make sure they get that water to drink and, you know, use for their cattle and farms. We got a lot of farms here in Texas. There's like a guy with a cow and a bunch of horses like right next to our office. But so with that being the case, we need to make sure that everybody that's trying to access the water has enough. And so my job is typically to teach people about what an aquifer is and how many different layers there are to it. So in case y'all are wondering, I built this myself because I wanted to show people maybe when we couldn't take some of our bigger models somewhere. But this hopefully shows you guys all of the different layers in an aquifer. So we see we've got these really old rocks at the bottom. And then we've got all of these other layers of sand and gravel. We've got our little, everybody sees the tiny little Play-Doh house, all that good stuff. So, oh, excellent, thank y'all, y'all are so nice. This is stuff, if you ever wanna build your own, you can get it at Walmart. This is like their normal aquarium and then all of the cool rocks and stuff. And I know it's just the anime eyes. I know it's not actually anime, of course. So in regards to all of this, when we're concerned about water and moving through all of the different rock layers, we can actually see the water pass through if we're very, very careful, okay? So I'm gonna make sure I can get it up to the camera. All right, everybody seeing all of those water layers. So it'll take a little bit, but all of the water will eventually make it through all of the layers, which is why we care so much in Texas about groundwater. We wanna make sure everybody has plenty for years to come. So we have this. So in case y'all are wondering, and anybody wants to build their own little mini aquifer at home, made out of like normal foods, this is what I typically bring to schools when we go to build mini aquifers together. So here are the materials that I have. This is actually pretty easy for you to build at home if you want, no big deal. So when we have an aquifer, it's a rock that stores water, right? Which means that we need to make sure we have all of the layers in the aquifer to make sure it works. So the first thing we're gonna go ahead and do, we need to make sure we have that sandstone that can make sure the water is available. So this is our sandstone right here. These are vanilla crackers from the Dollar Tree. So this is our edible aquifer that we're going to be creating. And we want to make sure we have that first layer of our aquifer in here. So here we go. We're going to go ahead and dump it. All right. There we go. So there is our aquifer, so to speak. Now, does everybody notice the holes in between all of the little pieces of crackers? Hopefully that gives you guys an idea of where the water normally sits in the rock. Because I know a lot of people, when we talk about rocks holding water, they look at a rock and they're like, Miss Jill, how in the world is water supposed to be in there? But it's all about those tiny little holes that we were talking about. So we got to go ahead and put some soil on our aquifer, right? Because this is not realistic. So let's go ahead and add some organic sediment. Let's go ahead and add this. And we see it's dark, right? Maybe there's some iron in there. Maybe there's some materials in there that we are interested in. So go ahead and dump some of those in. A little bit messy. There we go. Cool. So now we have our 2 layers of our aquifer. Now, it's not full, right? We don't have any of our water available. So we need to go ahead and add some of our precipitation, which is Sprite with some sprinkles in it. I wanted to make sure the Sprite was a decent color so we could make sure we see what's going on. But when we add this, I'm going to try to make sure I hold it in front of the camera. You guys are going to see what happens to the water after it rains pretty much, and how that water gets down to the aquifer. So we have the rain on our top layer. There we go. Do we see it moving through all of the different holes? And that starts the beginning of recharging our aquifer, filling it back up with water so we have more space for everybody else. And in case anybody's wondering, do we see that line right there? That like line from the Sprite? That is called something, got my little vocab sheet for you right here. That is called the water table. It's the start of the beginning of the aquifer. And so in case anybody was wanting to build this at home, you could always add some food coloring that's supposed to indicate contamination, and you'll watch it spread through all of the different layers. So while I'm not incredibly familiar with Florida geology, I have looked it up a little bit because I heard you guys were in Miami and I was like, I gotta make sure I know what's going on there. You guys do have aquifers like this actually in the state. They're made up out of sand, and you guys can study them and kind of check all of the different layers of what's going on. So this is just kind of a fun thing to remember about what's going on underneath your feet, because there's rocks there that are millions and millions of years old, but we don't always see them at the surface, but they're still working for us and we're still using them all of the time. And depending on the type of sedimentary rock that your aquifer is made out of, sometimes you end up with really nice looking crystals that grow out of it. But remember, all those crystals is because we had lots of cooling and we had lots of water that was introduced. So we end up with these. In case anybody's wondering, fool's gold, pyrite. This is what we've got here right now. So those are some cool things that we've got. But yeah, so this is kind of just a quick review of how weathering and erosion works. So hopefully you guys realize by the end of this, when we have a rock that's broken down from wind or rain or all that kind of stuff, it eventually is going to get softer and rounder as it's beaten up against other rocks. So a great example I could give you guys really quick, and then I'll double check on my time. This right here. Called Potassium Feldspar, in case anybody is wondering. It's a pink rock. We see this if anybody has ever seen granite or granite countertops. This is the mineral that makes granite pink, reddish looking. So that's what this is. Well, you guys notice that this is very sharp, right? We have a lot of pieces on this. It doesn't look very round. You could potentially cut yourself. This is an example of a rock that has not been weathered very much. So he's still really angular, and he's got a lot of pieces that are potentially showing that it hasn't weathered a whole lot. But as weathering goes on, you get to materials that, see, they're a little more rounded, but they've still got some sharp edges. And then finally, all the way to super rounded. So if you guys ever go out like in your backyard and you just want to like pick up a random rock or something, determining if it's really round or really sharp is going to tell you if it's been weathered or not. So that's kind of like a fun thing to see if you guys ever go outside and kind of get to check some samples of your own. But yes, so hopefully that's kind of helped y'all a little bit in regards to sort of how the rock cycle works on sort of this first part. Eventually, after our rocks become all of those little pieces and get stuck together, they eventually are going to be buried again, right? Because all rocks just end up being more rocks come and then dirt piles on top of them, and they go deeper and deeper into the Earth's surface. That's about the time when they start melting again, right? Because we know that the center of the Earth is very, very hot. So as we go deeper into the Earth, the temperatures are gonna go up. And so then we end up having our rocks melted all the way, and then we're back at the beginning of the rock cycle where we had lava and magma and things like that, and the rocks cool down and they start the whole thing again. So, Miss Garcia, how are we doing on time?
We have plenty of time. So if you take as much, if you wanted to cover a couple more things, there's no rush.
Excellent. Okay, wonderful. All right. Hopefully everybody is still good with hearing me and seeing me and stuff. So I guess a couple of the other samples I wanted to show you guys today are fossils, because I know I kind of showed them intermittently throughout the presentation. But here is an example of one of the cool ones that I got. I don't know if anybody recognizes this one. It looks a little similar to another sample that I had. So this is a really thick ammonite. Everybody can kind of see it's very, very wide. And if anybody notices, it kind of has like a rainbowy iridescence to it. That's because it has minerals on it called opal that have been incorporated into the sample. So it looks like this really cool rainbow when you turn it in the light. It is real. Yeah, no, I know that a lot of these samples look like they're fake, but I promise this is, I actually got this one from a lady that works near our offices. She likes to drop off fossils because she's got so many on her property. And that's where a lot of these have actually come from today. So yeah, so here's one of our ammonites. I already showed you guys the really cool pyrite crystal. These guys, everybody recognize these little fish right here. If I understand correctly, these are over 300 million years old. This is a really old fossil guy. He's been in really good condition. But if you look at it on the side, I know this is like the more boring part of it. Everybody see those kind of layers right there? That's sandstone that has been pressed all the way into its own rock. So the sand used to just be sitting there, and then it got pressed and pressed and pressed. It was like in a pressure cooker. And that's how the rocks end up kind of being what they are. Let's see, looking around. This is another cool one. In case anybody is wondering, like, how do crystals grow? What happens if crystals grow in certain areas? This is something called, ignore that little insignia, this is called a melocaria. I know it's got like a funky name, but what this is where you have cracks in a rock. See how we kind of had like the dark ones that started? But then another mineral will get in there through water. And that's where all of these light crystals come from, because the mineral will run through the rock, deposit all of the stuff that's in the water, and we end up with new crystals. So there's a lot of really cool geology stuff you guys can see if you ever get the opportunity to just go rock hunt or like check it out on the side of a highway. Usually those are good places to hunt. Let me go and see. Oh, in case anybody was wondering, when I was talking about weathering before, some of you guys have probably encountered really hard rocks, right? You've touched them before and you're like, Miss Jill, this isn't gonna break easily. I'm not really sure how that could happen. Well, depending on the type of mineral that you have, sometimes the rocks are made up of really, really soft minerals, which means it's really easy to break them down. So the two examples that I have for you guys today are gypsum and talc. And I'm going to show you guys the differences between these. So I know they look kind of similar. They just look like two gray minerals, but our fingernails, just fun fact for you guys, if you're looking at the hardness of minerals, our fingernails have a hardness of about 2.5, which means that we can scratch anything that's softer than a 2.5 mineral on our like international scale of hardness for minerals. So I'm going to go ahead and show you guys. This one is talc. It's made it makes talcum powder, you know, baby powder for babies and stuff. That's what this comes from. So we go ahead and take it. See that? I can just scratch it with, oh, as I dropped it in front of the camera, I can just scratch it with my fingernail. So this is an example of a really, really soft mineral. Here's another great example. This one you can actually see a little better when I scratch it. So I'm going to take my fingernails. Everybody see that? So this mineral is super, super soft, and it's a lot easier for it to be broken down. So you guys can kind of see now how some of this weathering actually happens pretty quickly if your rocks are sort of made out of all of these materials. Now, as things die, they are covered by all of the sediment and usually preserved. So here's an example. I'm going to try to hold it as best I can. Does everybody see that? This is a giant oyster that died and then was buried instantaneously. And so all of the rock that you see around it is sedimentary rock, sandstone and limestone. But the guy never had a chance to do anything but move. So he got buried. You can see there's the little mouthpieces. I think there would be a hinge somewhere back here, so he would kind of open up like that. But yeah, just depending on the area that you live in, you can find some of these fossils like right in your backyard or stuff like that. I'm glad y'all think they're cool. I'll make sure to include some pictures or something and send them to Miss Garcia if any of y'all really like these. So yeah, other than that, hopefully this has kind of helped you guys identify like why geology is important and why people study rocks, because most of the time it's things for asphalt, like, you know, driving around places. Geologists help come up with the materials to put down on the ground. If we've ever got rocks or stone in any kind of building, geologists were usually consulted to make sure that the rocks that they were building the area out of are good rocks and they're not going to fall apart anytime soon. So a lot of the times, you know, it's different geology, but it's still really exciting. So here we go. We've got one more quartz crystal here in case anybody wants to see like the actual growth of a quartz crystal. This one would have probably grown in water somewhere because everybody noticed it's actually a really nice shape other than it being broken here. So what that means is that wherever this crystal used to be in the earth, it had a lot of space to get really big and really tall. I know, right? They're pretty cool. So let's see, we got that. And then one other, I think I'll show you guys, this will be what I'll kind of end with. So like I was mentioning, water is probably one of the biggest things that we deal with in geology because water creates so much. It makes these rocks in all of these different shapes. It helps preserve some of these fossils. And depending on what's in the water, sometimes you can have little crystals grow all by themselves. These are called Beright Roses. I don't know if anybody has heard of these before. They're really big in Arkansas. So if anybody takes a trip to Arkansas and goes like rock hunting or fossil hunting out there in the mountains, this is what will typically grow. It's made out of something called barite, and it grows in these really cool patterns that kind of make it look like a rose. It did that all by itself. Like no one created this mineral to do this. This is all natural. So it's kind of exciting to see art in science occasionally. That's always a really fun thing. So if you guys have any questions for me involving any of these samples or anything in regards to like a geologist or what I do or like what geologists do in Texas, I'm happy to answer them. But otherwise, I appreciate y'all listening and paying attention.
Yay. So I actually have a lot of people in the chat who have a lot of questions. So what
excellent.
I is, yeah, why not ask your questions? Yeah, I see some virtual class. Yay. If you have a question like we normally do in reading class, give me a reaction. So a thumbs up. It could be in the chat box. It can be on your, the reactions on the bottom. And I'm going to go through and I'll unmute you guys so that you can ask your questions. So let's see. Let's start off with Layla. I'm going to unmute you so you can ask Miss Jill a question.
What's her name? Jill. Don't the crystal come from, does that type of crystal come from lava in the water?
Oh, that is a great question. So I would say this particular crystal probably grew in the water. The crystals that were grown from lava and magma and kind of like volcanoes, those actually look a little bit more like this. So we see how some of those rocks, they're really weird and angularly shaped because they were blown out of the volcano and then they were like stuffed on top of each other and then the rock came together. So I would probably say that the stuff that comes out of volcanoes has cooler, smaller crystals, and then there are a bunch of different colors because the magma is made up of all of these different minerals and it just ends up giving it like a crazy color. So that is an excellent question though.
Thank you, Layla. Does anyone else have a question? Let's see, Angela, I'm going to go ahead and mute you. Let's see.
Really? How did you get, how was that rock made right there with the two,
let's see. This guy?
No, the one that has the two, no, that one right there. That one right, no, the one in front of it. No, that one.
Okay, yes. I'm so sorry, we're gonna get this. Okay, which one?
That one. Yes.
Oh, excellent. Okay, cool. Awesome. Thank you for your patience. So excellent question here. With this particular sample, and I actually got this sample as a thank you for going to a conference. I probably wouldn't have been able to buy something like this myself. It would have been way too expensive. But if you look here, what geologists typically do is they start with the rock on the bottom. They say, what is going on here? And this rock is actually a limestone. So what that means is it's made up of tiny little critters that died in the ocean millions and millions of years ago, and all of their little exoskeletons got squished together to make another sample. So if I wanted to, remember how I had mentioned acid earlier with like sedimentary rocks and they react? If I wanted to, I could probably dump some acid on this and it would bubble and fizz, telling me that it's a sedimentary rock. I won't do that today, but most likely this one was formed in the oceans, in the shallow areas of the beaches, and then it all came together, and then these crystals grew after the fact. So excellent question though, that was really good.
I'm going to pause real quick because I have some people who I know need to leave. So if you do have to leave, I want you to stay and ask more questions. But I'm going to put a link in the chat box, and that's your exit survey for today. So we did something different today. We had a guest speaker. Y'all got to like see some things in action. So make sure to fill out that survey, letting me know what you liked about today's class, what you didn't, and then how you're doing if you have to leave. But I have a ton of people who still have more questions. So I'm just putting that in the chat box. So if you have to leave, it's there. You can take it before you leave, but stay and ask more questions. So let's see. I see a lot of people in the chat box. I'm gonna go ahead and unmute Jairis, and then Ivan, you're next.
The rock that you just had in your hand, is that from Florida? Because Ms. Garcia told us that limestones are from Florida.
Let me see. Could you repeat that really quick? I'm so sorry. My AirPod went out, I think.
The rock that you just had in your hand from Florida, because Ms. Garcia told us that limestones are from Florida.
Oh, are we talking about like the limestones and how they like react with the acid? Is that kind of what you were focusing on? I'm sorry. I want to make sure I can hear you correctly. I'm so sorry.
Yeah, Jairis, I think I know. I remember I think you said that I mentioned how limestone was a very popular rock in Florida. Is that what you're asking about? Yes. Okay. So I guess you should go more about limestone. Mm-hmm.
Sure, yeah, absolutely. So that's a big deal, or it's a cool, really popular rock in Florida because Florida is on the Gulf Coast, right? You guys are kind of this shape around the Gulf of Mexico. And so what typically happens is, remember how I had mentioned all of those little microorganisms that have all of their itty bitty little exoskeletons? Well, what happens is all of those exoskeletons, they're made out of something called calcium carbonate. Now, calcium carbonate, I'm sure you're like, Miss Jill, that's a big old chemical term. Hold on a second. But calcium carbonate is the exact same thing as Tums. Has anybody had Tums? Has anybody ever had to like take Tums to make your stomach okay? That's what calcium carbonate is. That's what limestone is. They're made out of the same things. So when we have Tums, normally people will get really good samples of limestone or calcium carbonate and grind them down and then make them into those like cute little berry flavored pellets. But in regards to limestone in Florida, you're going to see a ton of that because Florida is completely made out of sand and made out of old fossils because you guys live right on the coast. And you probably noticed that everything is really, really close to sea level. So limestone is made when all of those little microorganisms die, and then they slowly get packed and packed and packed because more microorganisms are dying and they're falling out of the ocean, right? So that gets squished and squished and squished. And eventually, if there's enough water flowing through and, you know, creating through all those cracks, that's how you end up with limestone. So, but great questions. Y'all are asking really good stuff.
Awesome job, Jyrese. Okay, I'm gonna go ahead and next is Zariah. Let me find you, Zariah, so I can unmute you. Go ahead, Zariah.
My question is, can two rocks like form together?
Oh, that is an excellent question. Absolutely, they can. So oftentimes, this is kind of some cool stuff. So let's say, for example, we've got that volcano that I was telling you guys about earlier, right? And it's got lava and the lava is oozing all over the place. It's getting onto like houses and roads and things like that. Well, that lava is super hot. And so if it reacts with maybe there was a limestone nearby, or maybe there was a sandstone nearby, what'll happen is as soon as that lava reacts, the rock underneath it changes. It becomes a completely different rock because it's being melted and pressure cooked at the same time. So you'll actually end up with, fun fact, you end up with metamorphic rocks, which is kind of this section here. So really good question, but yeah, I've seen rocks of all different kinds that are melded together. So it's a really fun thing to go and Google search if you're ever really bored.
Thank you, Zariah. Okay, let's see, let me find Ivan. Ivan, go ahead and ask your question.
Okay, so if some rocks go to the center of the earth, right? Like, does it affect it in any way?
Oh, that's an excellent question. So you guys are asking really good stuff. So typically when those rocks melt and they go underneath the surface of the earth, typically what'll happen is they like to stay in the mantle, meaning that most of the melted rocks will stay kind of close to the top of the earth. I will tell you that from what I've studied and what I've been taught, the center of the earth is so pressurized and so solid, well, most of it anyways, that most other rocks actually can't be introduced. So what they do is they like to stay melted in that mantle area right beneath the crust. So that way, if there's ever a crack in the crust, like we have a deep ocean trench, that lava immediately spews out and we have new rocks on the surface of the earth. So there's actually, in case y'all are curious, there are rocks at the center of the ocean that are 1 day old. They're like the youngest rocks that have existed on the planet. And those all happen in the oceans. But yeah, great question in regards to that. Most of them hang out in the mantle. I know the center of the core is iron and nickel, and it's solid. Because think about all the pressure of the whole world is focusing on this one central point of the earth. And so that's why normally you'll end up with really solid stuff there. But yeah, a lot of it stays melted and in the mantle. So great question though, awesome.
Awesome question, Ivan. Yamilet, did you still have a question?
How rocks are made?
Good question. So that's a big question to answer, but I can tell you for the most part, it starts off with that magma and that lava. So when we have liquid rock, that liquid rock is going to eventually get colder, right? And it's going to solidify. And so that's where we start off with our igneous rocks. That's where we start off with things like this, because they have the opportunity to cool. You have all these different colors now of all those different crystal grains. Now, excuse me, eventually we'll kind of go on to what I was talking about earlier with the rocks break down eventually and they move all over the earth. And so that's when we end up with sedimentary and metamorphic rocks, because they'll be pressure cooked and turned into something else. But most rocks are all begin at a volcano or lava or magma. So, good question though.
Awesome. Okay, who else has a question? You can give me a thumbs up, a reaction, put it in the chat. I'm going to go through and see. Jairus, you have another question? Let me unmute you. Go ahead.
How do the rocks get shaped?
Oh, that's a good question. So definitely has to do with what they're made out of. So you remember that mineral that I showed you earlier that like I could scratch with my fingernail? It was really, really easy to scratch. So these types of rocks typically are going to be shaped and turn into nice little round balls really, really easily. And that's because they're so soft. So if they're like, let's say this is being taken down a riverbed, right? Like it's being moved through the water and it's bumping into other rocks on the way, it's getting hit and stuff. All of those sharp edges are going to eventually round their way out. If you have a rock though that's really hard, it doesn't like to break very easily. This is a good one. I can't scratch this one with my finger at all. But this one in this instance is going to be really hard and jagged because the minerals are so tough, they're not going to break down. So great question. It's all the result of how tough is your rock or how tough is your mineral. That's going to determine its shape.
Awesome. Good one, Jairus. Anyone else have a question? Let's see. I'm going to go through and double check. This is your last chance to ask a geologist any questions you have about rocks, aquifers, anything we've talked about in class. Again, if you have your video up, that's okay. Just show me a reaction and I can unmute you.
You had some excellent questions today.
Yeah, those are awesome questions. Okay, so it seems like everyone got a chance to ask their questions. I'll leave the chat, so if you need to leave, you can leave. If you want to stay and ask more questions, that's also possible. Remember, before you leave, I'm going to put in the chat box one more time, and I'll post this on our class page. Jairus, I see you, don't worry. The link to the survey. So this is going to help me give you guys extra credit for today. So if you fill this out, I see that you filled it out, you'll get extra credit for coming to our meeting today. So again, if you leave, you can just say a thank you to Miss Garcia, Miss Jill in the chat for coming and speaking to you guys. Y'all had awesome questions and I'm super happy you asked them. So okay, anyone have any questions? Yeah, thank you, Jill. I see Jairus, yes, more questions. Go ahead. Let me unmute you. Sorry, go ahead.
Does it depend on what type of soil you have for the color of the rock?
Oh, that's a really good question. So yeah, actually, the type of rock actually influences the color of soil. So this one that I had kind of pulled out earlier, I'll take it out of the bag so y'all can see. You'll notice that really orange red color. So that is all based on the minerals that are in the soil, and the minerals all broke off of the rocks. So that's a really good observation. So if you ever see any really dark soil anywhere, that means it's got a lot of organic stuff in it. It's got a lot of iron. But if you see soil that maybe is like a lighter color, maybe kind of like this ugly tan shade or so to speak, that means that all of the helpful minerals have been washed away by the water. So this is stuff that you'd probably want to grow, maybe like a sunflower or some vegetables in. This, probably not. So that was a really good question though. Yeah, color definitely depends on it.
Good job, Jairus. Okay, Zariah also had a question, so Zariah, I'll unmute you.
One more question. I wanted to ask, how does can you give me one example of how rocks help life?
Oh yeah, no, that's a great question. Absolutely. So other than us getting our vitamins and minerals every single day from rocks, they actually also tell us where we're going and who we are. So surprisingly, we didn't actually know the age of the Earth until we studied these fossils in Australia. They're the only place that they can be found on the face of the Earth, and they're called stromatolites. But they are the rocks that are the oldest rocks that we can find on the face of the planet. So they tell us a little bit about, this is how long we've been here. This is what the Earth has been doing before we got here, things like that. So even though it kind of helps with medical and health and things, it also is an everyday life usage for people that work outdoors, for anybody that teaches anything about the Earth or environmental science. It definitely affects us in a bunch of different ways. But I would probably say tells us about the Earth and definitely helps us with our health. Those are really good questions. Nice.
Thank you, Zariah.
Thank you.
Ms. Woods, I'm going to go ahead and unmute you. Do you have a question?
Hi, how are you?
Good.
Thank you very much. Hi, how are you? I think this is like my 5th Zoom call, but it's been wonderful listening to you.
Thank
you. I had a question. It's actually a piggyback off of a question that another student asked, and it's regarding the color of the soils.
Yes,
like you see the light one, and some is really rich and dark. Is that would regions or places have a lot to do also with that? Like, do we see more of the darker soils, and like where will we see those type of soils?
Yes, ma'am. That is an excellent question. So the area definitely depends on what type of soil, you know, you're going to have there. So normally places that have large amounts of vegetation, really, really big, extensive tree systems and lots of vegetation on the ground will typically be the darker color that has more organic material in it. Usually because the plants continue to die, and so that organic material then stays in the soil and continues to enrich it. So that's typically where you find those good organic soils. The arid ones, or the things that kind of have nutrients and minerals that have been leached from them, this is what you typically find in desert environments or anything that's arid, because the topsoil usually can't stay put. And so you end up with these rocks underneath that all of the minerals have been leached, and you're usually just trying to do the best that you can with the topsoil available. But yeah, definitely arid environments. That was an excellent question, by the way.
Okay. Thank you. And I'm not a science person, but when she asked that, it kind of made me think of like, wonder, I never thought about that. Depending on, you know, your area, it would make sense that your soils would be, but I didn't know the rationale. Thank you very much.
Absolutely. Yeah,
Thank you.
Appreciate it.
Awesome questions, guys. Does anyone have any last questions for Miss Jill before we end our call? Y'all had great questions.
All right, thank you for listening.
Okay, if not, I'm going ahead and unmute everyone so we can all give a round of applause to Miss Jill for coming to our call. Okay, give me 3 seconds. I'm gonna unmute all of y'all, so just beware. Okay, can I get everyone to give a round of applause for Miss Jill while we thank her? Thank you.
Thank you. Thank you. Thank you.
Thank you.
Thank you.